Hello, it's Scott Manley here. Last month, I got to fly this. This is VTOL's Blackfly, now known as the Helix. It is an ultralight, electrically powered VTOL with 8 motors, 2 sets of wings, and room for just one pilot. And that is of course why I had spent a couple of days with their instructors learning to fly this in a simulator. And I say learning to fly, actually controlling this thing is trivial. It's no problem with anyone with a decent amount of video game and flying experience. What I really needed to train for though was if something went wrong. I needed to be absolutely sure that I would be able to handle any emergency should it present itself. And indeed, a lot of you were asking various questions about the vehicle's safety on the previous video. What happened if one of the propellers failed? What would happen if the batteries failed? Well, at the very least, if you were paying attention, we did actually do an engine out simulation where I basically had to land it. Now, the manual actually goes into a lot of detail about engine failure configurations, and if the system actually detects that one engine has failed, it will actually shut down or at least slow down the one which is diagonally opposite for cruise flight to basically eliminate any asymmetric thrust. So within its intended flight envelope, it has enough thrust to perform the landing if you have 2 of the 8 engines failed. Having said that, the system does state that if you lose 2 engines in a single quadrant, then the aircraft will not be flyable for landing and you should deploy the parachute. Oh yes, the parachute. Ballistic parachutes are becoming increasingly common in general aviation, and VTOL's Ultralight is no exception. In fact, the Ultralight rules that it's operating under allow extra mass above the basic budget if you are going to include a parachute, so it makes total sense for them to include it. Now, this design is launched by a mortar through the front of the vehicle, and it deploys very quickly. It's designed to deploy fully before the aircraft falls 200 feet. They actually have a performance diagram in the manual which shows that it can actually deploy sometimes below 200 feet, but 200 feet is sort of the baseline that should cover everything. So it's activated by a red control on the left front of the cockpit there. Basically pull this out, and to train, well, you don't have a fancy VR simulator, you have a nice haptic simulator, which is a piece of plywood with the relevant hardware and the circuit boards secured to it. And this is primarily so that new pilots can get an idea of how much force is needed. You see, what it does is it pulls this little line out from between these micro switches. If enough of those switches pop, then the parachute system triggers. So Sabrina set up a suitable training scenario.
Give me some examples of a scenario where you might want to pull the parachute over, making an emergency landing.
Well, I mean, if the vehicle is out of control in a manner which it's not responding, it's tumbling.
Yeah. So uncontrollable flight.
Right. If you've hit something and there is visible damage to your wings. Yeah. So anyway, like, I understand you have a lot of things before you need that. Yeah. Doing it slowly, that's to see like what sort of tension needs to go before it
Okay,
rings.
you're cruising around.
Wow, it's quite a lot, but if you just yank it, it goes so easily.
Yeah.
You gotta know you're gonna do it.
Right.
It's good though, because it's not something you're gonna accidentally pull.
So anyway, the parachute system, it runs off a separate battery that charges off the main one, but it's independent from the rest of the system. So if there's a problem with everything else, the parachute system will still work, but it will also still talk back to the computer. And one of the features that's mentioned is that if the parachute's deployed, the engines will shut down until it gets a radar signal close to the ground, in which case it will then try to fire the engines back up for a graceful landing, like it does here. And so one more step that I wanted was to look around the factory. And this was partly because, I wanted to see that these things were being built to high standards, but also because I was incredibly curious.
This is our final assembly area. So there's a few aircraft in different states of completion or assembly. A lot of times you'll see just the fuselage, and the wings go actually on a cart parallel to each other next to the fuselage. So that's how we'd store things in a trailer for transportation.
Yeah. That is Greg. He's currently Product Management Director. He helped set this up, but in the past, he led GNC and firmware. That means he's my kind of person.
But this is a flying V3 aircraft that we take to all sorts of shows and things. And you can see with it disassembled, we kind of have a jig that keeps all the connectors where they should be so that they're convenient when you put the wing on here and
reassemble
connect
things.
it.
Yeah.
I mean, with V3, it's like you're driving a race car. It's very Spartan, very lightweight, not a lot of fit and finish. We have different seats that we drop in for different sized people because we want to make sure that your head is in the same place.
Right,
you
so
have,
booster cushions, basically.
yeah, so you have the same field of view. The parachute system, we wanted it completely isolated from the rest of the system. So the flight control software is not in the loop. That is, it's always available if you need it, and there's no way that that can be kind of taken out of commission.
So it has an independent battery or something?
It does.
And so that charges off the main battery, I guess, and just
Exactly.
keeps, okay.
Yeah, but it can hold charge for a very, very long time
Right.
independently. So it goes through a bunch of pre-flight checks, and there's like one-way communication that reports that it's good to go. It could fire if you wanted it to. But aside from that, there's no other interaction, and it's purely like an electromechanical connection between you pulling and the inflator being set off.
Yeah. And this launches through the front here, right? This is this panel here.
Yeah.
Right, that would be...
Yeah, so there's a cylinder in there holding the parachute, and then it's on the other side of the aircraft, but there are risers that are connected to the wing fuselage, like hard points.
Is this part of the parachute system here? This
That
cord?
strap.
Yeah, that strap, yeah.
Exactly. We have a replaceable wear strip on the bottom.
Okay.
So if you're landing on, you can pretty much land on any surface. We mostly do grass, but if you're landing on asphalt or something, it can wear over time.
Over time, yeah.
So we wanted that to be something that's like
Easily replaceable. Yeah, it'd be just like changing tires on a plane.
Exactly. Yeah.
One of the interesting facts that we discussed was that the original carbon fiber structures which were constructed used to use a wet layup process, but as they've migrated towards the V4 design, they're moving to like a pre-preg material which should be more consistent and lighter because it has less excess resin.
I just love the fact that, you're like carbon fiber, space-age material shaped by plywood,
Oh yeah.
right?
That's pretty common.
Plywood is still
and MDF are used.
It's also a composite, right?
It's true, yeah.
In another part of the facility, they're developing, building, testing the electronics that go into the aircraft. And they have this unit which basically has them all stacked up in a rack.
So this is one of our hardware and loop setups. Basically just diagnostic software, nothing too fancy, but it's giving us tons of telemetry from all the systems involved. So this actually has all the motors, battery packs, motor controllers, servos, all the electronics that would be in a full aircraft.
Yeah.
But in a really, really convenient way for us to swap them out, test things, attach, debug probes to different boards.
Yeah.
It's running X-Plane as well, so we can run the full control
So this is
system.
running X-Plane too, huh?
Yeah, which is not really meant for testing the control system, but it does close the loop and allow us to check the rest of the systems.
Yeah.
Gives us a basic flight model. So basically, we have a lot of capabilities here to manufacture from raw materials the motors. We bring in, the steel for the stators and all the wiring, and we do everything ourselves internally. So we can prototype and tweak things pretty quickly. And we've actually made some big improvements to the motors lately. These ones you can kind of see we've experimented with different windings and bus bars and things, and very crude ways of balancing.
Yeah.
But
you're not just buying these motors off the internet.
No,
that's the thing.
We have some of the highest power density motors that we're aware of. That really is part of what makes this possible in the ultralight category.
Yeah.
So each of our propulsion systems, meaning the battery, ESC, motor, and propeller, as a propulsion system, can put out about 125 to 130 pounds of thrust. And gross takeoff weight of the aircraft is 568 pounds or so. So we've got pretty much a 2-to-1 thrust to weight ratio. So this is a dyno setup.
The dyno,
So
yes.
This basically lets us run our motor under test, and we can simulate different loads at different speeds. So this is how we really qualify our designs.
So okay, I see these. These are your power cables, and these are like checking the current
Current
sensors. Yeah. It's cool, and basic understanding of physics is sometimes useful.
So we know exactly what goes into the motor and exactly what comes out on the other end. Over here, we have our prop lab. So you can kind of peek in here, but this is where we run the motors, the whole propulsion system. We can kind of do it in a bunch of different ways. We can do external power supply or using the actual battery pack from the aircraft.
Yeah.
But we can do endurance testing, so we'll just do cycles where we charge and fly and charge and fly. Mm-hmm. We can replay past flights on the motors. We can push them up to full power basically with a prop. It's just static conditions again, so it doesn't replicate the airflow. Mm-hmm. But yeah, and you can see we've run wing sections. Yep. We've done tests with gyroscopic loading, so where we're pitching the wing while running the prop.
This is one that's got the 3 redundant
exactly. So
boards.
You can clearly see the triple redundant flight computers and all their sensors on board. And there's harnesses that connect all of them, so they're constantly sharing data with each other, and the system, including the motors and motor controllers, are kind of voting on which one to be using.
Yeah.
And then there's the nice big 12-inch display now, high brightness.
Oh, so this is a bigger display that's going into future ones.
Exactly. So this is going into the new aircraft. Gives you all the essential information, nice and clear.
And then there was a fascinating piece of company history on display.
This might be the first public unveiling of Mini-Me. So we were using this back when I joined in 2016, in 2017 I think, to do some development and testing of our control system. We already had full-scale aircraft at that point, but this was just an easy way to get up new ideas. In the end, these off-the-shelf hobby-grade ESCs and motors were so much less reliable than our own systems. We just went back to full scale. But yeah, so we would fly it with an RC controller rate mode, and we were developing attitude stabilization, GPS, like position control.
But this was after you'd built full-scale versions.
So this was kind of in between V1 and V2 Blackfly aircraft.
Okay. But I mean, it has all the same components, basically. And it even has an air probe out the front.
Yeah, nice. It's the same in principle. It flew pretty different, as you can imagine.
I was delighted to see that they had Snoopy at the controls, because this is, of course, just a modern interpretation of a red biplane. And so that is very much a brief version of the tour. There was a lot of stuff that I couldn't actually talk about. But from going with the company's past, I was looking forward to the future where I was going to be flying this. And the flights were going to take place in a little private airfield on Monterey Bay. This is actually pretty close to Watsonville Airport near Santa Cruz, and I actually flew over it when performing an instrument approach a few days before. And my instructor was nice enough to snap this image because, of course, when you're on an instrument approach, you can't see outside. They already had the aircraft out of the hangar and prepped, but, of course, as a good pilot, you're supposed to do a walk around, a pre-flight, to make sure that all the bits are where they are supposed to be and not falling off.
Aircraft exterior, we're clear FOD except for us. Canopy, nice and clean. Let's get a little dirty now, but it's good. Canopy locking pin, it's here, it works. Pitot tube mounts.
So we have our pitot tube covers on right now. We want to give each one a little wiggle and make sure that it's secure.
You mean give the tube a wiggle?
Yes.
Okay. And then this.
And while you're giving the pitot tubes a wiggle, you also can give the GPS sensors a wiggle as well.
Okay, you want to make sure these are firmly attached. So these are combined GPS and pitot tubes, right? Radar altimeter. So the radar altimeters are these boxes underneath the wing,
yes,
right?
You can reach it from under there. You can also reach it from here. You just want to give it a little wiggle.
Okay, make sure it's attached.
As well.
Now there's one on each side, on each wing, so there's 4 of these in total, and they're all pointed slightly different directions. These tell you when you're close to the ground so that you can actually land correctly. Right, and then these are your heat sinks. So,
our heat sinks, yes.
Right, so there's heat
to
sink
help dissipate
fans. Where would those be? Visually inside
fins.
Fins. Oh, fins.
Yeah. No, there's no fans on that.
Sorry.
Oh, there are some big fans in front of the heat sinks that might help a little bit.
Yeah. There you go, big fans.
We're going to give a spin.
Okay.
And the other way as well.
Good. Okay.
And we're just checking the noise, making sure it's smooth and consistent.
Yeah.
And then once we're done checking the props, we're going to leave them horizontal, parallel to the leading edge, That tells us and other people that we've pre-flighted this section of the aircraft.
Good strategy. Check our aileron. You can hear the actuator running, and it does come in and out beautifully. And it resets back to the neutral position again. And there is our radar sensor here. Much better view from this angle here.
Okay.
Good.
And we've completed our pre-flight.
Awesome.
You ready to go fly?
I'm ready to go fly
Let's
again
do
and
it.
again. These straps are a lot easier than the Alpha Jet. Pilot harness secured tightest, radio comms checked, canopy secured, not yet. So we need this. Comes over. Cleared for hover takeoff.
So this is the first flight, and it's basically straight up and then a little bit of yaw left and right and then back down. And in the bottom left, that is data that came from the flight computer that I asked for. So you can see not only the overall RPM, but the different RPM between the front and the rear wings. During that initial pitch up, the front props are 4 times faster than the rear until vertical. So differential throttle is one side of the control system and the other is the elevons. Now as I reach my altitude, I twist the stick, and if you look carefully on the back wing there, you can see the elevons operating as I turn the stick to yaw. And if you're an aircraft designer, you might think that's kind of odd because elevons are supposed to deal with pitch and roll, not yaw. But because I'm pointing basically straight up, the roll is a yaw relative to the horizon, so the controls automatically adjust for the vehicle orientation. And as we turn the camera, yeah, you can see the vehicle orientation is very much straight up and down. All of the weight of the vehicle is being carried on those motors. That's why they're running at 3,800 RPM. The temperature's rising, the charge is depleting. This is a very inefficient way to fly, but it's how you land. And when you get close to the surface, you pull the trigger and the auto land system kicks in, and you could go hands off at this point as it lands itself. And finally, to shut down all the motors, I have to use a button combo I like to call the Vulcan neck pinch.
Okay, we're all clear. Motor temps 126 was the peak.
Thank you. You don't need to repeat them back. I have them on.
I'm just acting like I know what I'm doing.
You do know what you're doing.
Okay.
Great job! Way to go!
Hey, high
First
five!
flight.
Awesome.
How did it feel?
It felt pretty good. It felt like we were moving forwards. I wanted to go backwards initially to make sure I wasn't going to roll onto the concrete, but that was the main
Okay
thing.
to land on the concrete. Yeah.
But yeah, it was actually definitely more intense than the sim. I was like,
Yeah.
oh, wait, all my positions, all my instruments are in slightly different places, but let's make sure I hit my altitudes and orientations, so. We're going to begin a yaw, teardrop around, rejoin the runway, fly up here, and then as we're doing that, we're going to start descending. Obviously, 50 feet is the altitude we're going to maintain until we get over the landing site, then we're going to descend and then hover and land.
Good.
So Flight 3 was going to be my first opportunity to fly forwards, but I was restricted to doing this in hover mode. In hover mode, if you let go of the stick, then it would slow you right back down to 0, so you had to keep the stick moving forwards. Hover mode also limits you to just over 30 knots and it's less efficient. So this is us in hover, and you can see the speed is about 30 knots and the props are running at about 2,900 RPM. We're going fast enough that the wings are actually giving us some lift, so the motors don't need to run at full tilt. That means the battery isn't decreasing as quickly and the motor temperatures aren't rising. So now, since I'm still in hover mode, I need to twist the stick to turn, and it turns more like a yaw than a roll. So the controls are accounting for the different orientation of the vehicle. If you look at the third line down, you can actually see the heading pitch and roll of the aircraft. Its pitch up is about 35 degrees, which is so steep that most aircraft would be stalled, but because this is blowing so much air across the wings with those propellers, it's still generating lift from those. And of course, the moment I get close to my landing site, I'm just going to let go of the stick and it'll drop back to the center. The aircraft will pitch up to slow down, and then I can use the rocker to descend and then pull the trigger for an automatic landing. The real skill involved here is getting as close to your landing site as possible before you let go of the stick and pull into a hover. That way you're not spending a lot of time and motor heating adjusting your position prior to landing.
Very nice landing. You're not even in the caution range.
it finally felt like it was flying, right?
Exactly.
A lot of the time you feel like when you're hovering, you feel like you're sort of just hanging on, clawing at the air.
Yeah.
You can feel it's working hard, and as soon as you start to pick up speed, it just really gets smooth.
Until it's getting the lift, everything quiets down a little bit.
Yeah, it's becoming at one with the sky, right? That's,
Exactly.
yeah. You know, it's sort of a vibe thing. Once it's moving, it feels natural. And like also once you just had the motion, it was very easy to figure out where I was and where I should be. So now we got to charge it up to like a more, or what are we doing next?
Yep, still 100%.
Okay, that's going to take a while.
Flight.
Yeah, so let's...
It'll really be more like 30 minutes because it charges up pretty fast.
You look really comfortable in it. You're already a professional.
Confirm. Check immediate area for safety. We're all good.
So Flight 4 was going to be my first chance to actually leave the airfield and transition into cruise mode.
Colin, all clear?
It's also the last time I wore a camera on my head, but it's the one that gives you the best view of the control screen.
Clear for ignition.
Have to hold the button to start the motors. So during initial startup, the motors will spin at like 30 RPM, and the way they spin, you're supposed to check to make sure they're rotating in the correct direction.
In, confirm.
Select the joystick by holding the trigger.
Right stick. Elevon movements.
This is your classic controls are free and correct check.
Elevon's free and clear. No alerts. Check ground wind. We have a very small amount of headwind. Area takeoff path clear. We're all good. Cleared for hover takeoff, departing to the south, I guess.
I'm giggling because even although this is like a private frequency with hardly anyone on it, I'm still stressed about what the people on the other end are thinking. So this was going to be my first real flight in this, and immediately after takeoff I perform a 180 degree yaw, push forwards on the stick, accelerate forwards, and once I reach 100 feet I pull the trigger and transition into cruise mode. The nose drops another 20 degrees down to 15 degrees of pitch, but I'm still climbing up to 250 feet, but once I get there I'm gonna stop the climb and watch the RPM. Now you all probably noticed a big drop in that number and probably even heard, let me tell you, when you hear your engine doing that in a real plane, you immediately start thinking that there's some sort of problem with the engine. But in this case, that was just the control system adjusting to the new requested climb rate. The funny thing is, I hadn't expected it to happen, even although I knew enough that I should have figured out that it would happen. Regardless, when the thing pitches forward, you have this amazing view out the front. That canopy comes way down and you can see way down over the nose. This is much better visibility than any aircraft I have ever flown. I was so glad that these test flights took place in such a picturesque location.
As we made that first turn, we're at 90% power.
Perfect.
These fields off the end of the runway that I'm flying around are about just under a mile across, so each lap turns out to be just over 2 miles. Have I mentioned that this thing literally flies itself? Anyway, I'm not going to include the whole flight because I'm going to run out of things to say, but I do want to give you an idea of how loud it is. For this flight I actually placed a camera at the end of the runway, so I flew over it. And so through most of this, the aircraft was about half a mile away. And while it's hard to tell just how loud something is, just listen to the background. You can hear birds chirping. And if we skip forward a bit, you can hear what it'll sound like when the aircraft flies over. sure there's some comment to be made about how our eVTOLs will blot out the sun. Essentially in flight this is quieter than most aircraft because it doesn't have an internal combustion engine and an exhaust system. It doesn't have a big propeller that's beating the air. It has lots of smaller propellers that are sort of beating the air a little faster. That means that it's buzzy rather than growly. I'm going to be honest and say it sounds like an orchestra of weed whackers, but it's a lot more fun to use.
Beautiful landing.
How was cruise? How did that feel?
Oh, cruise felt even more normal. Right, again, once it picked up the cruise, once the lift started going in, the engines the motors start to, work a whole lot less difficult. And it's beautiful turning out over the ocean. Could, really start to see everything out there. I mean, there was a lot of people down in the field, but, so I buzzed them. I hope they weren't too concerned.
Any animals in the water?
No, you know what? We did actually have some birds come up right as I was flying across final, or turning to final. They got a really good look at them, but
nice.
I made a point to not turn into them, obviously, but they were at my altitude coming across my path, so I delayed turn to final for that.
At your speed, they're pretty good at avoiding you.
Yeah. I know it's not like we're flying something that's really fast, but they were pretty big as well, so I was happy to not get too close to them.
Now I want to show you Flight 5 because that's one where I actually got a screen capture of the in-flight display. It's a pretty easy to understand display, but I understand that there are changes in newer versions. All the same, you have like important operational numbers down the left, your altitude, your motor temps, your charge. On the top you have some navigational information, and then you have this map in the middle. You'll see it says transition available. That's my cue to pull the trigger and transition into cruise mode. The compass display in the middle is also useful because it shows you where the wind is coming from, and you're supposed to land facing into the wind.
Hey, coming back the other way, I'm showing a 12 knot headwind, so I'm going to set up for the 90 approach.
Perfect.
We have a bunch of birds near me, all clear though.
They're checking you out.
One part of this flight was to demonstrate an approach to the runway in the opposite direction, but since the wind was blowing in an unfavourable direction, I was pretty sure that I wasn't going to have this proceed all the way to a touchdown.
Go around.
Going around.
It's not exactly a complicated missed approach procedure like I have to deal with in bigger planes, but as we've transitioned into the hover, we've been running the engines more harder, and the motor temperatures will have risen. And so if you've got the battery power, you're expected to go out and fly around and cruise for a bit to let the temperatures drop down so you can make another approach attempt and not have to worry about overheating your motors. And so one more lap in the pattern also gave me an opportunity, once again, to demonstrate how this thing practically flies itself.
Don't forget to do your rock star hands once you're straight and level.
I was just thinking about doing that.
Hey, this time.
Ah, look at that.
Yeah.
How do you feel?
Oh, wow. Well, that one was great because I get to really look up the beach and see out over the ocean. Yeah. And we had this wonderful flock of birds just spiraling around the middle of our pattern that we flew over the field. Didn't have to worry about people in the field. They weren't anywhere near our track, and I was worried about that earlier. But as a pilot who flies things where I'm manually controlling the throttle, hearing the aircraft automatically adjusting the throttles with alarming speed is alarming. It comes up and down very, very quickly, but you just got to listen to that and then see that the airspeeds are correct, and it's really just the fly-by-wire doing its thing. And it's amazing that once I got into that pattern around the field and I dialed in 250 feet, it just held that rock solid. It was wonderful. Like even you could feel the wind coming and buffeting every now and then. I think there's a bit of wind coming over the ocean and it's hitting those cliffs and it maybe rolls around a bit. But the aircraft is totally able to fly through that and maintain what you tell it to do. And that's the whole thing about fly-by-wire, right?
Exactly.
It's you know, and you know more about this than me, right?
Yeah. I mean, it's taken a long time to get it to this point, but it's really smooth and really easy.
Yeah, I know. And sometimes, you know, I would like it to go faster, but you know, those are the rules.
We'll get there, yeah.
It is wonderful. You know, it's great to actually take an opportunity to sort of look around and see the propellers, the props, like all doing their thing, right?
Yeah.
You know, you're sort of surrounded by all this hardware working in concert.
Yeah.
With each other.
In my initial flights, I always forgot to look back over my shoulder and see the rear wing and just kind of appreciate everything that's going on.
Yeah.
To make this possible.
I know it is wonderful. Like,
and you can watch the elevons as well. I don't know if you noticed them, but when you basically have your hand off the stick, they're
doing stuff.
They're very active.
Right. I mean, you know, I think it's fascinating. We have this like ground checklist item where we're pushing the stick and making sure the elevons move the directions they're supposed to go. But when you're in flight, you can take your hand off the stick and they're just doing their own thing, right?
You're not controlling them that directly.
You're not that direct.
That pre-flight check.
That's an entirely different software mode. That's you know, that's not like you're in flight or anything.
Yeah.
Pre-flight check is just to make sure they're operational.
Yeah, and they turn the right way. You know, there's nothing going the wrong direction.
Okay, clear for takeoff. And so for the final flight of the day, this was basically supposed to be the check ride. I was expected to demonstrate all the skills I'd learned. Sabrina, as the instructor, had explained what I needed to do, what maneuvers I had to incorporate. I had to incorporate both types of approach. I needed to incorporate a go-around, so I came up with a flight plan, which would involve that, but I said, you know, why don't we include a low pass down the runway at like 100 feet? Why don't we put some like graceful S-turns over the hangars so we can get the aircraft turning? Let's coordinate with the drone camera to make it look great. And I think it worked out. Well, okay, my S-turns were actually really janky. I'm still getting used to the stick, but you know, the drone was well positioned. I came around this turn, I could see it in front of me. I didn't think I was going to hit it at any point, but just to be sure, it lifted up in altitude a bit and looked down on me as I'm flying over the beach and into the cliffs. This is just joy watching this in retrospect. It's not fast, it doesn't have a long range, it can land almost anywhere, it is incredibly easy to fly. It gives you amazing views. If I owned a bunch of land in the middle of nowhere, this would be a fantastic way to explore it. For more urban areas, it's a bit more complicated because ultralight rules really limit where you can actually fly over. First of all, there's airspace, and then secondly, you're not really supposed to fly too close to people. But those are kind of the current rules, and there's always talk of advanced air mobility rules that might change this, that might allow certified versions of aircraft like this to operate much closer to people in and around buildings for basic transportation. It is definitely much more a regulatory problem than it is a technological problem.
Good landing!
Ah, shit. Fuck. Yeah! There you go, there's your tradition, right?
Oh my god.
Nice. Congrats, that looked great.
Oh! Oh! Yeah!
There's your thumbnail.
I've done a few of those. Oh boy! Okay.
You're an eVTOL pilot.
Yay! Official! Not just a simulated pilot, but an actual pilot.
Yeah.
And the only thing I realized as I was coming around there, it's like I didn't agree to an altitude for this final loop around, so I just brought up to 200. I figured 250 was too much.
Well, thank you, Scott, for being such a great student.
Oh, thank you for being such a great teacher.
A really good job in the sim. You were done in, I think it was under 3 days.
2 days.
2 days.
And this is the
days.
third, I guess.
Yeah.
So, yeah.
One of the fastest.
Exactly.
Okay.
Yep.
Well, that's pretty cool. You gotta have the chart, but you don't want to make it too competitive, right?
Do you think it's kind of odd doing your training this fast compared to, because you're a private pilot?
I'll be honest, I thought I could have probably done a lot of the sim stuff in 1 day.
Really?
Like, I just felt, but I think it's probably good to split it over 2 days.
Like sufficient training that you got before you went and flew?
Yeah, but I would say that you probably do need to have at least 2 days of sim training because you've got time between those days to forget everything and then relearn it.
Yep.
You want to make sure that people can remember.
Yeah, it's not a race.
It's not a race. But I think it was actually, it felt like the right amount of training for someone like me, private pilot with a lot of video game experience.
Yeah.
Well, that's an interesting balance because a lot of private pilots sometimes have to unlearn things or they're not as flexible. But I think the gaming gives you more plasticity. Like
because you get like a million different games with different control schemes.
Exactly.
So yeah, it totally makes sense.
Yeah.
So once again, thanks to Pivotal for letting me do this, for taking me through the training and letting me actually fly this. I think it's fascinating that there aren't many people in the world that have so far learned to fly something like this. So on one hand, it is a pretty exclusive club, but on the other hand, it is incredibly easy, and anybody could learn to do this. The thing practically flies itself with the fly-by-wire. It's easier than riding a bike. And equally, while this aircraft has limited capabilities because it's intended to operate under the Part 103 Ultralight certification, this illustrates that the basic concept of operations is sound, and should opportunities exist to scale it up, well, Pivotal will be well positioned to do that. While other eVTOL manufacturers are still working their way through the certification process, Pivotal have a website where you can order one of these today and know when it will get shipped and delivered. You'll just have to learn to fly it first. I'm Scott Manley. Fly safe.